Hello, everyone. In modern society, electric motors play an irreplaceable role in industrial production, transportation, household appliances, and other fields, serving as essential equipment that drives social development and daily life. Electric motors are electromagnetic devices that achieve the conversion or transmission of electrical energy based on the law of electromagnetic induction. They are devices that convert electrical energy into mechanical energy by generating a magnetic field and electric current through electromagnetic induction. An electric motor consists primarily of a stator and a rotor. Its functions include driving mechanical equipment, providing power, and controlling motion. Learning to measure the insulation resistance of electric motors is crucial because insulation resistance is a key indicator in electrical systems. It reflects the condition of equipment or circuit's insulation. Low insulation resistance in an electric motor can lead to leakage currents, potentially causing short circuits or even fires. Therefore, regular testing of the insulation resistance of electric motors helps identify potential safety hazards early, ensuring the safety of both equipment and personnel. Furthermore, insulation resistance testing allows assessment of equipment's operational status, facilitating timely maintenance and prolonging its operational lifespan. Therefore, understanding how to measure the insulation resistance of electric motors is fundamental knowledge in the field of electrical engineering and an essential skill for electrical professionals. In our previous lesson, we learned how to use a Megohmmeter and how to assess its functionality. Now, let's delve into using the Megohmmeter to measure the insulation resistance of electric motors. In practical work processes, we need to choose the appropriate instrument according to our work site tasks, mainly depending on the instrument's range. Physical demonstration. Preparation before measurement. Before using the Megohmmeter, we need to ensure personal protection. Since this involves live electrical work, you should wear a safety helmet, work clothes, insulated shoes, and insulated gloves. Additionally, due to the hazardous nature of working with live electricity, ensure there is supervision by a qualified person during actual field operations. Electric motor insulation resistance test, a phase-to-phase and phase-to-ground first. Inspect the instruments, perform an open circuit test and short circuit test as covered in the previous lesson, and ensure the instruments are in good condition. Proceed with the open circuit and short circuit tests. After passing the tests, first turn off the power of the equipment being tested, discharge, and then use a voltage tester to check the discharge status of the motor's three-phase windings. After ensuring there is no power, remove all external connection wires and their connections from the equipment and clean the parts to be tested. For the connections, first measure the insulation resistance relative to the casing or ground wire. Generally, connect the casing terminal first. Connect the black wire to the E terminal for grounding. Then connect the red wire to the L terminal and subsequently to U1, V1, and W1. Then, slowly and then quickly, rotate the handle at 120 revolutions per minute, and take measurements for 1 minute, waiting for the pointer to stabilize. After reading, slowly detach the wires for discharging. Next, measure the phase-to-phase insulation resistance. Connect the red and black wires, or L and E terminals, to any two of the phase-to-phase insulation resistance, and then slowly and quickly, rotate the handle at 120 revolutions per minute to take the measurements for 1 minute, wait for the pointer to stabilize, and read while shaking. After reading, slowly detach the wires for discharging. After measurement, the results should be judged. In general, the insulation of the phase-to-casing, of phase-to-ground, and phase-to-phase, low-voltage motors are qualified as long as they are greater than 0.5 megohms and can be put into use. In this lesson, we learned about using a Megohmmeter to measure the insulation resistance of electric motors. Here are the precautions for using a Megohmmeter. 1. Before operation, ensure the Megohmmeter is placed on a stable and level surface to prevent measurement inaccuracies. 2. Clean the surface of the object being measured thoroughly to ensure there is no dirt or debris that could affect the accuracy of the measurement. 3. While operating the Megohmmeter, press down on the dial with your hand to stabilize it, but do not cover the scale dial. 4. Avoid touching the measurement parts and terminals of the Megohmmeter with your hands until the Megohmmeter has stopped rotating and the equipment has been discharged to prevent electric shock. 5. Maintain a proper distance between the clips of the wires to prevent short circuits during the connection process. Ensure that the connection wires between the Megohmmeter and the equipment being tested are single insulated wires. Use dedicated measurement cables. Do not twist two testing wires together, and avoid contact with the equipment or ground to prevent errors caused by poor insulation of the wires. Through this lesson, we have not only mastered the method of using a Megohmmeter to measure the insulation resistance of electric motors, but also enhanced our awareness of safety. I hope everyone can apply this knowledge in practical work to ensure the safe operation of electric motors and contribute to societal stability and development. Thank you all for your participation, and I hope this lesson has been helpful to everyone.